Alright, so our warm-up on 10.6, we're using the quadratic formula. If I were you, I would write the quadratic formula on your note card. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order to use this, we need our equation in the form ax squared plus bx plus c equal to 0 or equal to y. So we have these two on the same side, but we need to move this 5x over to the other side. So those will eliminate. And write your x squareds first. We have 6x squared plus 5x minus 6. Now we know a is 6, b is 5, and c is a negative 6. So let's plug in what we know into our quadratic formula. We have x equals a negative b, and b is 5, plus or minus the square root of b squared, or 5 squared, minus 4 times a times c. A is 6, and c is a negative 6, all over 2 times a, and a is 6. So if we simplify this, we have negative 5 plus or minus the square root of 5 squared. Well, 5 times 5 is 25. Then we have negative times a positive times a negative. I know two negatives are going to make a positive. So I have 6 times 4 is 24. And 24 times 6, you can plug it in your calculator. I'm going to multiply it out here. 6 times 4 is 24. 6 times 2 is 12. 14. You get 144. All over 6 times 2, which is 12. So then, simplifying again, we have negative 5 plus or minus the square root. If we add 144 plus 25, we get 169, all over 12. Now, if I were you, I would plug the square root of 169 into our calculator to see if it equals a nice number or not. So we're going to type in the square root of 169, and we get 13. So we really have negative 5 plus or minus 13 over 12. So we have our two answers, one with a positive and one with a negative. Negative 5 plus 13 over 12, and negative 5 minus 13 over 12. Let's solve both. So negative 5 plus 13 is 8. 8 divided by 12 is 0.6 repeating. And the other one, we have negative 5 minus 13. Oops, typed that in wrong. Negative 5 minus 13 is negative 18. Divided by 12, we get negative 1.5. So I know I did that a little bit quickly, but all we did was simplify our quadratic formula that we have up here and follow our order of operations: exponents, then multiplying, then adding and subtracting. So those would be our two places where this graph would cross the x-axis. So we just recorded or reviewed 10.6. I'm going to go on to 10.7 and then we'll go back to 10.4. 10.7 was interpreting the discriminant, which is part of the quadratic formula that we used right back here. This was our quadratic equation or formula. The discriminant is just this part underneath the square root. So that part is b squared minus 4ac. And we use our equation ax squared plus bx plus c to plug in what we know, a, b, and c. When we get an answer, let's say we get positive 12. Since we know this is really under the square root in our quadratic equation, you could take the square root of 12 and you get two answers, a positive or a negative. A more familiar answer, or equation, or problem, would be the square root of 9, which we know is 3. However, 3 squared or negative 3 squared would both give us 9. So we know there are two answers. So you would write, if you get a positive answer, two solutions. If you solve the discriminant, this piece here, and you get 0, you can take the square root of 0. Square root of 0 is just 0. That is one solution. That means on our graph, we would be crossing the x-axis at 1 point, or touching at 1 point. If it's touching at 2 points, that means our parabola is crossing twice. Could be opening up, could be opening down, but 2 spots. And then finally, if we solve our discriminant b squared minus 4ac and we get an answer like negative number, like negative 25, you cannot take the square root of a negative number, so this would be no solution. Meaning, if we were to graph this, it would not be touching the x-axis. So that was all we did on 10.7. 10.4 was solving using our square roots. So if we had an equation that looked like this, 9x squared equal to 16, we would solve this by dividing by 9, and we'd get x squared equal to 16 over 9. Now I know that's not going to be a nice number, but I know these are both perfect squares, so I'm going to leave it as a fraction. And then last, the opposite of a square would be to take the square root. But remember, every time you take the square root, you could have 2 answers. So our answer is going to be positive or negative. And we have the square root of 16 on the top, which is really just 4. And the square root of 9 on the bottom, which is really just 3. Make sure you write both answers. A couple other things about 10.4. I'm going to give us more space down here. Feel free to pause this if I'm going too quickly here. On 10.4, we also solved some that were maybe a little bit more complex, like 3x squared minus 5 equal to 14, let's say. I'll make it 13, so we get a nice number here. And so when we solve this one, we would have to add 5 first, and we'd get 3x squared equal to 18, and divide by 3. We'd get x squared equal to 6, and then we'd have to plug that square root of 6 into our calculator. You would have 2 answers, remember, positive or negative, and then you would need to plug that in your calculator. It would be 2 point something, round to 1 or 2 decimals. The last thing with 10.4, what if we have a square root, or a square like x plus 2 squared equal to 5? Well, we can get rid of the square by taking the square root on both sides. So those would cancel and leave us with just x plus 2 equal to positive or negative square root of 5. We don't know what the square root of 5 is. We could just leave it as square root of 5. But then we need to get x by itself, so I would need to subtract 2. So I would have x equal to a negative 2 plus or minus the square root of 5. Always write the number first. So in my calculator, I would have 2 answers. X equals negative 2 plus the square root of 5, or x equals negative 2 minus the square root of 5. You would plug both of those in, and we would get our 2 answers. I have no idea what that is. You would need to do that for yourself. If you have any questions, please let me know. Otherwise, good luck on your test.